Yeah, dear ladies and gentlemen, my name is Karl-Heinz Biersack, and I would like to welcome you on behalf of Dalma Electronic to our webinar. Originally, we have planned for this webinar to offer at the end of the webinar a session with question and answers. But due to the fact that we have more than 100 participants, we cannot ensure individual and detailed answers to all. Therefore, we decided we will send you after the webinar a follow-up email with the link to the webinar recording, with the PDF of the used PowerPoint presentation and additional information, as well as my contact details. You can send me your questions or any demand which you have per email, and I will individually answer and support you. The topic of our today's webinar is airfield intrusion and other risks, counter-strategy for airports with smart video technology made in Germany, made by Dahlmeier. Our agenda for our webinar is, first we will talk about challenges and current events. We will talk about different technologies for airfield security. We will have a comparison of camera technologies with real world use cases, and of course also takeaways for you. I would like to say a few words about our company, about Dalma Electronic. The headquarters is located in the city of Regensburg, which is in the south of Germany. Since 1984, we are active in the video and security technology, and we develop and produce our products here in Regensburg. Therefore, we call it Made in Germany. Our main customers are airports, critical infrastructures, logistics, industries, cities, stadiums, casinos, and so on. In 2011, we got the patent approval for our panoma multifocal multisensor technology. During our webinar, I will introduce you this unique technology more in detail. We are also very proud that our products and solution, they comply with the European GDPR and also the American NDAA regulations. Currently, we have approximately 400 employees. Yeah, which kind of solutions does Dahlmeier offer for airports? We do not only offer solutions for perimeter or airfield observation. We have, for example, also a special solution to observe an entire runway with a length of up to 3 kilometers from one installation point with 2 camera systems. We have solutions for apron, inside the terminal, of course, for parking. And we have a solution which is called in the market virtual airport, but also a solution which is a remote tower solution, which we developed together with one of our partners. Challenges and current events. The Airport Business Magazine in the USA made a security survey this year with airport responsibles, and they described their biggest concerns as shown here in the graphic. As first is insider threats, second place is cybersecurity, and third place is already airfield security. Of course, there are more different topics which they mention, but today we will speak about the airfield security. The interviewed persons, they express, or I can say 45% from them express that they see a lack of camera perimeter alert technology. 31% they see a concern regarding drone incursions. 28 regarding the inadequate fencing which they have, and so on. Significant increase in number of incidents. We experience in Germany and in Europe unauthorized intrusions into airfields, and we can really say that the number of incidents is dramatically or significantly increasing. This leads to an impairment of air traffic, up to temporary suspension of flight operations. And this again leads to problems for the airport operators, for the airlines, for the passengers, and is creating high costs. What is the legal situation? We as Daimler, we do not know in detail all the different local acts, directives, and regulations. But for Germany, we can say that the operator of an aerodrome is obliged to secure airside areas against authorized access. And this is stated in the German Aviation Security Act. Regarding critical infrastructure in general, we identify increasing requirements on resilience. In Europe, for example, we have a new European directive regarding physical security. Regarding cybersecurity, we have also a new directive called NIS2. Technologies for airfield security. Of course, there are different technologies and solution approaches available. For example, fence detection, which is shown here in the upper left picture. A fence detection detects vibration, cutting, intrusion into the airfield. The reaction can come possibly too late because the alarm event is only sent when the fence is already cut or someone overjump already the fence. And an additional visual camera system, or let me call it police patrol, is needed for verification of such an alarm. Then we see also infrared or microwave barriers. They detect also movement of persons inside a specific area. The reaction is only possible after a successful intrusion. This means only when persons already inside the airfield and they are crossing such a barrier, infrared or microwave, the event is coming and the alarm is coming, and this is already quite late. Also, a visual camera system or again, police patrol is needed in order to verify such an alarm event. Then we can also see radar systems. Of course, they can monitor very large areas. Our experience is that they are poor detecting slow movements. This means when persons or objects are moving quite slowly, radar technology has a difficulty really to detect and further to track them. And also for a radar system, a visual camera system, or a police patrol is required to verify such an alarm. We see also the use of thermal cameras. They are good for areas where you have low visibility, for example, during night where you don't have an illumination. But the disadvantage of thermal camera technology is they provide pictures only in grayscale, and such pictures cannot be used in front of the court as an evidence. This means also by use of thermal cameras, a visual camera technology or a police patrol is needed to verify such an alarm event. We will also talk about different visual camera technologies. Here in this slide, we see now a megapixel camera, and it doesn't matter if it is a 4K resolution, 16 megapixel, 20 megapixel resolution. Such a single sensor megapixel camera has a certain disadvantage because it cannot capture large areas and surfaces in sufficient resolution. This means the resolution in distance is not sufficient anymore. And the resolutions provided by such single sensor cameras, they cannot be used in front of courts, not for a proper identification, and also video analytic requires a certain and high resolution and high quality picture that video analytic can work properly. Another visual camera technology is PTZ camera. I guess all of you know PTZ cameras. In case of an alarm event, the PTZ camera will be navigated to the relevant alarm area. But possibly there is no high resolution recording of the incident because the PTZ camera is controlled to the alarm area only after the alarm event is received automatically or, of course, manually. And a PTZ camera provides only one zoom at a time. There is no recording of the overall image. You can only record what is shown and provided by the camera. It is not suitable for intrusion detection because it is movable. It could be in wide angle mode, in zoom in mode. It could look to the left, it could look to the right. Therefore, the configuration and the use of video analytic for intrusion is not possible. Mostly, those PTZ cameras are used in combination with other detection systems. They provide the alarm, and a PTZ dome camera is used for verification purposes. Now I would like to introduce you the Dallmayr Panamera technology. We are calling the Panamera technology a multifocal multi-sensor system. A Panamera combines up to 8 sensors of different focal lengths in one camera system. Each image area is captured with specialized lens in the highest possible resolution. Now I would like to explain you Panamera technology based on the overview picture what we see here. One sensor and one lens observes here in this example on the upper left side marked as number 1 the area in very far distance from the camera system. We use a second encoder and sensor to observe the middle area of this far distance area. We use a third sensor to observe the upper right and far distance area. And for the far territory, we use the sensors 4 and 5. For the middle range in distance, we use a dedicated sensor and lens. In this case, it is our number 6. For the near area, we use encoder and sensor number 7. And as overview for the entire camera system, we use the sensor number 8, which is also used for the control of the entire camera system. And all those video streams, they are electronically stitched together so that an operator operates only one camera system and not 8 individual cameras. Panamera combines 8 sensors with different focal lengths in one camera. Each image area is captured with a specialized lens. This guarantees high resolution in every image area. On the right side, you see, for example, the example marked with the letter B. This is in quite far distance. The distance was calculated here with 160 meters. And in the overview, it is already hard for the operator to identify and understand all the details, all the actions in the image. But the Panamera camera covers, records everything in high resolution, so nothing is left for the lost for the operator. The example A is in approximately 80-meter distance and C is in the near distance. This means we can still read the number plates. And a Panamera systems offers unlimited virtual PT sets in the live image and in the recording. This means in the overview picture here, which is marked with Panamera, we see the entire observation area, and an operator can open for himself an unlimited number of split view and zoom factors out of this overall image and display for him the required area in the required zoom factor. We realize this because we stream the video streams from a Panamera system as multicast into the network, and therefore an unlimited number of operators can use the same video stream and can individually open dedicated splits with individual zoom factor. Compared with a PTZ camera, a PTZ camera can only be controlled from one person, and all other operators can only see the area this lead operator has selected. And a PTZ camera system cannot offer the overall view and the zoom factor in parallel, only one of it. Here in this example, I would like to explain you a little bit more in detail what we mean with virtual PTZ. The picture which you currently see at the bottom, this is the overview image of 4 Panamera systems which are stitched together to form for an operator 1 camera systems. And for a human operator, of course, it would be difficult to see all the distance, all the details also in far distance, but everything is available and everything is recorded in the background. Now you see in the overview picture a blue rectangle, which is in quite far distance. And on the upper split screen, you see now the detail view. This means we can electronically have a zoom factor, and this is the resolution of the signage where you can still read the letters. We have an additional rectangle. In the overview, it is hard to identify that this is a person, but when we go into the zoom factor and we use the resolution a Panamera system is offering, then we can see it is a person at the apron. We have another section which is in further distance. Here we can see 2 persons. They are active in loading goods to the aircraft. We have another blue rectangle which is in far distance, and we can also see that this is a signage and we can read 30-12D. On the next blue rectangle, we see an aircraft in far distance. The distance is approximately 2 or 2.2 kilometers. It is not the intention of the installed camera system here to observe the runway, but this is a side effect that we can still see details also from the runway. Then again, two examples where we can see the number of the aircraft. The next is ground service vehicles, and again, numbering of the aircraft. So here in this video, you see in the middle section the overview picture, which displays the Dahlmeier test site, which we have installed for video analytic tests. And at the left and right split views, you can see the details the panoma system can provide to the operator. Again, for a human operator, when he would only use the overview picture, it would be difficult really to see the small details, the persons, the actions the persons are executing. Therefore, we have the panoma system. A panoma system can provide all the details and high resolution also in distance. We have another example from this airport where we display the picture quality in distances of 140 or 250 meters. I believe it is quite impressive to see such a resolution and all the details in so far distances. The next example, what I would like to show to you, is from a real perimeter installation. This is an airport where our camera technology has to observe a perimeter. The length of the perimeter is approximately 350 meter. And here in 270 meter, you can see this Volkswagen transporter in high resolution. And high resolution, of course, is also required that video analytic can properly work. Panoma benefits at the airfield or perimeter. Permanent overview is available and recorded, and unlimited number of virtual PT sets are possible in the live image and also possible in the recording. We consider a panoma system as the ideal solution as for optical verification and analytic of large areas and long distances. Event notification and the ability to intervene before airfield intrusion. In the display picture, you see the installation of a panoma system on a pole. Here, the panoma with the pole bracket is directed a little bit to the, or is moved a little bit to the left. This means the view of the panoma can already see objects in the outside or in the public area. And of course, due to the high resolution, classify the object if it is really a human or if it is an animal. And the analytic can also analyze what is going on. If people are longer in a specific section, if they are just walking by, if there is loitering, if they do something. And such an event can be forwarded to the security or to the police for verification. This means maybe already prior that someone can really enter an airfield, the panoma technology helps to understand the situation and provides a better awareness. This leads also to a more efficient use of staff because you don't have to execute permanent police patrols. The technology can help and provide events for verification, and then the police or the security can make dedicated action when something happens. The recordings from panoma camera systems can also be used as evidence in courts because the resolution is that high that an identification is possible. Panoma camera technology is equipped with video analytic. In our days, we always talk about artificial intelligence and neuronal networks. Of course, this technology is also used in the analytic of the panoma in order to significantly reduce any false alarms. Due to the fact that a panoma has built-in video analytic, we can again have a more efficient deployment of stuff. We have a verification of events also from other detection systems. It is not a must that the panoma system is used as a standalone solution. We have also applications and projects where we use panoma technology in combination with other and additional detection systems, but it is not in every project required. In the next few slides, I would like to talk about the total cost of ownership over 5 years for a perimeter observation application. And I would like to compare panoma technology with conventional camera technology. The initial investment in the camera technology in the product itself for panoma is a little bit higher because a panoma system can include up to 8 4K sensors with dedicated lenses. Therefore, such a camera system must be more expensive than a single sensor camera. But when we reflect on the infrastructure costs, due to the fact that a panoma camera system can observe very long distances, we need significantly less camera systems, which results in less poles for the cameras, less foundations, and therefore we have also less infrastructure costs. The installation for the panoma systems is cheaper because when you need a cherry picker to install camera systems at the pole and you have only 1/3 of the quantity of cameras to be installed, the installation costs must be cheaper. Also, when we talk about maintenance, because a video surveillance system requires also maintenance, also the cameras requires from time to time cleaning. You have to clean much less cameras, therefore you have also less costs. And also when we talk about the operation, it is much more efficient if an operator has to manage 30 camera systems instead of 90 camera systems or 100 camera systems. Therefore, the operation of the system costs also less, and it results in a duration of 5 years when we talk or reflect to the total cost of ownership, also in cost saving. We can say one single panoma replaces 3 conventional cameras, and this statement is already a minimum statement. It depends on the geometry, on the project requirements, because a panoma can look much further if a panoma can replace 3 or up to 4 or 5 single sensor cameras. This must be evaluated in an individual engineering. The Dallmayr products and solutions, they are not proprietary. This means we have integrations with other detection systems, like they are shown here with NAVTEC radar, with FLIR, with thermal cameras, but also with fence detection systems. And our camera technology and panoma technology is of course, already integrated in various video and security management systems. Here in this slide, I show only 3 vendors: Advances, Genetec, Milestone, but there are already other integrations ongoing. And an important aspect for the airport, our cameras and panoma solutions, they can be also integrated in airport operation management systems to provide different departments like apron management, like air traffic controller, like security, the information our camera technology provides in order that they have a visual verification of any area and of a specific situation provided by one camera system. Here in this slide, we mention only some of our customers. Of course, we have customers in Germany, in Italy, in Denmark, in Iceland, in Turkey, in Spain, in the US, in China, in Thailand, in the Philippines, and in other countries. We cannot mention all here, but if you are interested in establishing a contact to one of our existing customers, please send me an email and I will establish a connection that you can talk with our customers about Daimler Electronic, about the technology, and also about the experience they made with Daimler. Yeah, what are the takeaways for you? Choosing the right technology enables effective airfield security. The right camera technology is important for the verification of alarms, faster response times, admissibility in court. AI-based video analytic minimize false alarms and increase the efficiency of staff deployment. Daimler and our partners, we consider us as your experts for video technology at your airport. And we have 3 invitations for you. Of course, you can visit us in Regensburg and visit our panoma test site, where we have a complete perimeter protection system built up. But I understand that this is not possible for all of you because you're located in different countries, also in different continents. But the offer is there. You are welcome to visit us. Or as alternative, you can schedule with us or with one of our partners an on-site demo. This means we come to your airport, we build up a panoma or camera system for 1 or 2 days, and you can see at your airport the performance and the quality such a system can provide to you. And the third offer is you can schedule another online meeting with us, with me, with our local partner, with our subsidiary, in order to discuss your demand, your interest, and also your further questions. I want to say thank you very much for your participation and for your attention. And I look forward to receive from you your feedback and also questions. And let us stay in contact. Thank you and bye-bye.